In this video, we're going to talk about section 8.1 in our book, Solving Triangles with Right Angles. So in this chapter, we're going to solve triangles in many different forms. We're starting with ones that have right angles, so right triangles. We're going to measure the cloud ceiling. So a scientist shines a laser straight up to make a spot on the cloud. A second scientist that's 2 kilometers away measures the angle of elevation from the ground to the spot and finds out that that's 35 degrees. So we are told that a cloud ceiling greater than 800 meters is considered safe for flying, and our question is it safe to fly? So if we want to call maybe h this height of the cloud ceiling there, then in our triangle we can see that here's the 2 kilometers, which is 2,000 meters. Then the trig function we want is a tangent. So the tangent of 35 degrees is going to be the h over 2,000. And that means that 2,000 times the tangent of 35 degrees is going to be the height of that cloud ceiling. And if we go to our calculator, then I'm getting that makes the height 1,400.415. That's going to be in meters. And since that is greater than the 800, then we can say yes, it is safe to fly. Okay, so let's slide this up a little bit. Now we're going to consider the triangle ABC, and we know that the right angle is at angle C, and side length A is 8 and side length B is 15. And we'll hear throughout this chapter the directions will be solve the triangle. And what that means is we want to find all the missing sides and angles. So we know angle C is 90 degrees. We know that side length A is 8 and side length B is 15. So we want to find the third side. So we're going to try to find out what is C. And we're also going to try to figure out what is angle A and angle B. So to find side C, we can use the Pythagorean Theorem. So we can say that C squared is going to be 8 squared plus 15 squared. So that's 64 plus 225, and that's 289. And you can use your calculator, or if you're good at these, you might know that that means that C is 17. So there's one of the 3 things we have to find. Now we need to find angle A, and we can do that one of several ways. We can pick 2 of those sides. It doesn't much matter. I think I'm going to go with the ones that were given to us. So we can say that the tangent of angle A is the opposite over the adjacent, and that means that angle A will be the inverse tangent of 8 over 15. And I'm going to grab my calculator and go second tangent of 8 divided by 15, and that's 28.072. I'm going to call that 28. I'm going to round to 1 decimal place and call that 28.1 degrees. Then angle B, we can do several ways now. We could subtract from 180 using the 90 and the 28.1. I think I'll just do that. So we can say angle B is going to be the 180 minus the 90 minus the 28.1 degrees. And so that is going to be, if I go 90 minus 28.1, that's going to be 61.9 degrees. And we have solved that triangle. Okay, let's try another one. So here's triangle PQR, and we know that Q is the right angle, and that side length Q is going to be 5, and side length P is going to be 4. So we need to find R, and then we need to find angle P and angle Q. So to find the R, we can use our Pythagorean theorem. So we have 5 squared will be R squared plus the 4 squared, or you may recognize that as a 3, 4, 5 triangle. It's going to be 25 minus 16 is R squared, and that means that R is going to be 3. So that's the first thing we had to find. Now to find angle P, again, I'm going to use the ones that were given to us. So we knew the 4 and we knew the 5. So 4 is the opposite side and 5 is the hypotenuse. So I'm going to say that the sine of angle P is the opposite over the hypotenuse. So that means that P will be the inverse sine of 4/5. So on my calculator, I'm going to go inverse sine of 4/5, and that looks like 53.130. I'm going to call that 53.1 degrees to the nearest tenth. And so then again for Q, the 180 minus the 90 degree angle of, we already know Q, so I'm looking for, I guess, angle R. So the 180 minus the 90 is 90, and so R is going to be the 90 minus R 53.1 degrees. And so the 90 minus the 53.1 is going to be 36.9 degrees. Okay, let's slide up here. So the grade of a road is calculated from its vertical rise per 100 feet. So for example, an 8% grade means that as you travel 100 feet horizontally, you're going to rise 8 feet vertically. So using that idea, if we know the road rises at an angle of 6 degrees, what will its grade be? So we're looking for a percent here. So we're going to say here's our 6 degree angle. We want to know there's the 100 feet, and we need to know what is that x going to be so that we can make it into a percent. So the trig function is going to be that the tangent of 6 degrees is going to be the opposite over the adjacent. And so that means that 100 times the tangent of 6 degrees is going to be our vertical rise. So 100 times the tangent of 6 degrees, I'm getting to be 10.510. 10.510. So that is going to make the grade, so that 10.510 over 100 is going to be a 10.51% grade. Okay? All right, let's see what else we can do. So a road has a grade of 4.7%. What angle does that road make with horizontal? So let's see if we can visualize what's going on here. If it has a 4.7% grade, then when you go 100 feet horizontally, you're going to go 4.7 feet up. And we would like to know what is the angle that makes with horizontal. So that means that the tangent of theta will be 4.7 over 100. And that means that theta will be the inverse tangent of 4.7 over 100. So I'm going to go inverse second tangent of 4.7 divided by 100, and I'm getting 2.691 degrees, so I'm going to call that 2.7 degrees. Whoops, 2.7 degrees. Okay, here's a different kind of question. So a line through the origin passes through the point 16 comma B and forms an angle of 50 degrees. And we want to know what that B is. So imagine that we're at an angle of 50 degrees. So I'm going to say something like about there. There's our 50-degree angle, and that's going to contain the point. It's going to pass through the point that is 16 comma B, and we would like to know what is that B. So in our triangle that we formed, the x value is going to be the horizontal, and the y coordinate is going to be the vertical, and that's going to lead to a trig function. So tangent of 50 degrees is the opposite over the adjacent. So the b is going to be 16 times the tangent of 50 degrees. We'll take that to our calculator, 16 tangent 50, and I'm getting 19.068. 19.068. That is our value of B. All right, very good.